Hello, welcome back to Chapter 9, Section 7, Solving Quadratic Equations Using Square Roots. And this is the application problem. And I didn't realize this. I wonder if I changed it for the other ones. Yes, I did. That's why. It was just this one. So I'm going to sneak this in real quick. This is actually example 4. Sorry about that. Okay. So this is kind of contrived a little bit, but you got to understand that for Algebra 1 and even some of the problems we do in Algebra 2 and Geometry, the problems are really set up to demonstrate the skill, where like a real life problem actually has multiple skills and a bunch of advanced mathematics. So problems like this I always have kind of a little bit of a hard time with, like, why does it have to be this way? But the thing is that this is the actual, like, for this, a zookeeper is trying to enclose a pen, okay? Well, you've never seen something like this at the zoo. You've seen complex enclosures. Like if you've been to the Minnesota Zoo, the bear enclosure is just amazing. Each little part in designing that involved the geometry and algebra. It's just those problems end up being a little more complicated if you get into like architecture and engineering. Okay, so anyway, so what I'm trying to say is just go with it, all right? A zookeeper is going to be buying fencing to enclose a pen that's going to keep some animal in there, all right? I don't know what animal is, probably a vicious ferret, who knows? The pen is going to be an isosceles right triangle, just like the shape that you see. That's kind of convenient. Isosceles right triangles are actually kind of easy to understand, easier than more complex shapes. There's already a fence on this side, so there's already a fence from here to here. And of course there's a path right here too, so people are going to walk along, look over, they're going to be like, why is that animal sleeping? Which always happens whenever I go to the zoo. The zookeeper can buy fencing in whole feet only. Oh, I skipped part. The area has to be 4,500 square feet. So we're trying to give some space to this animal. Okay, how many feet of fencing should the zookeeper buy to put a fence here and a fence here? Got it. All right. So the area is going to be 4,500 square feet. The area of a triangle, any triangle, which includes this one, is going to be 1/2 times the base of the triangle times the height of the triangle. And the base and the height have to be at right angles to each other. Well, since this is a right triangle, that's just going to be these two sides. We call them the legs of the right triangle, but you don't need to know that right now. Okay, so what it turns out is that the base and the height are going to be the same. That's the number I'm looking for. So this area is actually going to be 1/2 of x times x, because these two are the same. The base and the height are the same. And that area is going to be 4,500 square feet. Okay. So let's do some math here. I get 1/2, let's simplify, times x to the second power. That makes this a quadratic. It's kind of nice that they picked the same thing here, isn't it? Equals 4,500. The opposite of multiplying by 1/2 is to divide by 1/2. But like I said earlier, we don't divide. We multiply by the inverse, which in this case is called the reciprocal. So I'm going to multiply both sides by 2. 2 times 1/2 equals 1, and I just get x to the second power. 4,500 times 2 is going to be 9,000. And you can do that on the calculator, that's fine. Let's take a square root. Let's take a square root. Don't forget you always get 2. And this is where I'm going to have to grab my friend here. Take the square root of 9,000. And I get about, I don't know if you can see that, there's a little bit of a glare, 94.8. Now, okay, so here's kind of a cheat. It says that the zookeeper can only go in whole feet. That means no parts of a foot. So 94.868, the next closest is going to be 95. And of course, if they really want it to be exactly 4,500 square feet, they're going to have to like cut part of the fence. Probably what they'll do is they'll use all of it and just give the critter a little bit extra room. But anyway, So I get x, and I'm going to use these wavy equal lines again, is going to be approximately plus or minus 95 feet. Okay, I always get two solutions to a quadratic equation. Everything from here is just algebra, but this actually comes from we'll call it a story problem, a real life problem, an application problem. So that means now I have to look at my solution and see if it actually makes sense in the application. 95 feet would be fine, okay? So this would be, here's my triangle, try to draw it, didn't draw it far enough. This would be 95, this would be 95. And let's just do a real quick check. If I do exactly 95, clear? I do 95 times 95. See, I get that extra 25. And then I'm going to divide that by 2 because it's 1/2 base times height. I'm going to have an extra 12.5 square feet if I do that. But that's okay. It's not smaller. I probably want to round up. There's probably some sort of limit for like how much I can use, you know, whatever the critter is that I have in there. Okay, so that works. So it looks like that's going to work. What about negative? Well, okay, it doesn't make sense to have negative 95 feet of fencing. Yeah, that doesn't make sense. I mean, what does that mean? Like you owe the store 95? I can't even wrap my head around it. Okay, so I only choose the positive after I get that from algebra. Then I look at the problem and say, well, actually I can throw out one of those problems because it doesn't make sense. So you can say that this is about, and here's something else that I forgot to mention, this is about 190 total feet of fence. Why is it, wait, where'd the 190 come from? Because you need to buy fence that goes from here to here. Both of them are 95, so just added them together. Okay, that's all. All right, we'll see you in the next video.